Siemens manual starter protectors provide short circuit protection for the motors they are connected to. If the branch circuit protector is rated for the combined amperage of both motors, additional individual short circuit protection is unnecessary. Follow these steps to ensure proper protection. Firstly, check the nameplate of each motor to determine their full load current or flaw. Secondly, add the full load amp of both motors together to get the total full load amp. Thirdly, select a branch circuit protector that is rated for at least the total full load amp. For example, if each motor has a full load amp of 50 amps, a branch circuit protector rated for at least 100 amps is needed. Locate the branch circuit protector as close as possible to the motors to ensure maximum protection. Understanding motor protection involves several key concepts, including short circuit protection, overload protection, and the roles of different protective devices such as manual motor starters, contactors, and branch circuit protection devices. Motors, being inductive loads, can draw significantly higher current during startup compared to their normal running current. This inrush current, also known as locked rotor current, can be several times the full load amp of the motor. Protective devices must be able to withstand this inrush current without tripping unnecessarily while still providing adequate protection against overloads and short circuits. A short circuit is an abnormal condition in an electrical circuit where current flows through an unintended low resistance path. This can occur due to insulation failure, physical damage to conductors, or other faults. Short circuits result in a rapid and excessive flow of current, which can cause overheating, fires, and damage to equipment. Short circuit protection devices are designed to quickly interrupt the circuit in the event of a short circuit, preventing catastrophic damage. Overload protection, on the other hand, is designed to protect the motor from prolonged overcurrent conditions that can cause overheating and insulation damage. Overloads typically occur when the motor is subjected to excessive mechanical load, causing it to draw more current than its rated full load amp. Overload protection devices, such as thermal overload relays, are designed to trip after a certain period of time when the current exceeds the motor's full load amp. Manual motor starters combine the functions of a manual disconnect switch, overload protection, and short circuit protection in a single device. They are typically used for smaller motors where remote control is not required. The manual starter provides a means to manually start and stop the motor, as well as to protect it from overloads and short circuits. The Siemens manual starter protectors are specifically designed to provide short circuit protection for motors. They use magnetic trip elements to quickly interrupt the circuit in the event of a short circuit. These devices are typically used in conjunction with contactors to provide remote control and additional protection features. A contactor is an electrically controlled switch used to control the flow of current to a motor or other electrical load. Contactors are typically controlled by a remote switch or controller and are used to start and stop motors, as well as to provide overload and short circuit protection. In motor control circuits, contactors are often used in conjunction with manual motor starters or motor protection relays to provide a complete motor control and protection solution. The branch circuit protector is a circuit breaker or fuse that protects the branch circuit wiring from overcurrents and short circuits. It is typically located in the electrical panel and provides protection for all of the devices connected to the branch circuit, including the motor and its associated control components. The branch circuit protector must be properly sized to protect the wiring and equipment connected to the circuit. The National Electrical Code, or NEC, provides guidelines for sizing branch circuit protectors for motor circuits. The size of the branch circuit protector is typically based on the full load amp of the motor, as well as the type of motor and the starting method used. NEC Section 430 covers the requirements for motor circuits, including branch circuit protection, overload protection, and short circuit protection. When sizing a branch circuit protector for multiple motors connected to the same circuit, it is important to consider the combined full load amp of all of the motors. The branch circuit protector must be sized to carry the total full load amp of all of the motors, as well as any additional loads connected to the circuit. If the branch circuit protector is not properly sized, it may trip unnecessarily or may not provide adequate protection in the event of a short circuit or overload. In the example provided, there are two 50 horsepower motors, each with a Siemens manual starter protector and contactor in one control panel. To determine whether additional individual short circuit protection is required for each motor, it is necessary to calculate the total full load amp of both motors and ensure that the branch circuit protector is sized accordingly. The full load amp of a motor can be found in the motor's nameplate. The nameplate typically provides information such as the motor's horsepower, voltage, full load amp, and service factor. The full load amp is the amount of current the motor draws when operating at its rated horsepower and voltage. Once the full load amp of each motor has been determined, the total full load amp can be calculated by adding the individual full load amp values together. For example, if each motor has a full load amp of 50 amps, the total full load amp would be 100 amps. The branch circuit protector must be rated for at least the total full load amp of all of the motors connected to the circuit. In addition, the branch circuit protector must be able to withstand the inrush current of the motors during startup. The NEC provides guidelines for sizing branch circuit protectors for motor circuits, taking into account the motor's full load amp, the type of motor, and the starting method used. It is important to consult the NEC to ensure that the branch circuit protector is properly sized for the application. In some cases, it may be necessary to use a larger branch circuit protector than the total full load amp of the motors to accommodate the inrush current. However, the branch circuit protector should not be oversized to the point where it no longer provides adequate protection against short circuits and overloads. The location of the branch circuit protector is also important. The branch circuit protector should be located as close as possible to the motors to ensure maximum protection. This minimizes the length of the conductors between the branch circuit protector and the motors, reducing the risk of voltage drop and improving the effectiveness of the short circuit protection. If the branch circuit protector is located far away from the motors, the conductors may be subjected to excessive current during a short circuit, potentially causing damage before the branch circuit protector trips. In summary, the Siemens manual starter protectors provide short circuit protection for the motors. As long as the branch circuit protector is rated for the combined amperage of both motors, additional individual short circuit protection is not required. To ensure proper protection, follow these steps. Firstly, check the nameplate of each motor to determine their full load current. Secondly, add the full load amp of both motors together to get the total full load amp. Thirdly, select a branch circuit protector that is rated for at least the total full load amp. Locate the branch circuit protector as close as possible to the motors to ensure maximum protection. Consulting the NEC and a qualified electrician is always recommended to ensure that the motor circuit is properly designed and protected. Remember that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with the relevant codes and safety practices. By following these guidelines and taking appropriate precautions, you can ensure the safe and reliable operation of your motor control circuits. In a scenario where each 50 horsepower motor has a full load amp of around 65 amps at 480 volts, the total full load amp for both motors would be 130 amps. According to NEC Table 430.52, the maximum rating or setting of a motor branch circuit short circuit and ground fault protective device for a standard motor is typically 250% of the motor's full load amp for an inverse time circuit breaker. However, this percentage can vary depending on the type of motor and the specific application. For two motors in the same circuit, you would apply this to each motor individually when determining the maximum allowable breaker size for each motor. Then, you'd need to ensure that the overall breaker size doesn't exceed what's allowed for the conductors. The conductors supplying the motors must have an ampacity of not less than 125% of the motor's full load amp, according to NEC 430.22. For each motor, that would be 65 amps multiplied by 1.25, which equals 81.25 amps. Since there are two motors, you would need to ensure that the conductors are sized to carry at least 81.25 amps for each motor. Typically, you would look at NEC Table 310.16 to determine the appropriate conductor size based on its ampacity. The Siemens manual starter protectors are designed to provide short circuit and overload protection for the motors. These devices typically have adjustable trip settings that allow you to customize the protection to the specific characteristics of the motor. When selecting a manual starter protector, it is important to choose one that is properly sized for the motor's full load amp and that has the appropriate trip settings. The manual starter protector should be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. Also keep in mind that voltage drop can occur in long conductor runs, which can affect motor performance. It's crucial to calculate the voltage drop to ensure it remains within acceptable limits, typically no more than 5% from the source to the motor. If the voltage drop is too high, you may need to increase the conductor size to reduce resistance. Finally, ensure that all components used in the motor circuit are properly rated for the voltage and current levels involved. Using components that are not rated for the application can lead to equipment failure and safety hazards. By following these guidelines and consulting the NEC and a qualified electrician, you can ensure that your motor circuits are properly designed, protected, and installed for safe and reliable operation.